So now we'd like to ask Mr. Eli Kintish to begin the panel discussion.
Okay, so our first speaker will be Michael Miller, who's the Director of Environment for EPRI.
Good morning, everyone. It's a pleasure to be here this morning and chat with you for a few minutes. Good, thank you. What I'm going to be talking about here in my 5 to 8 minutes is something that I usually spend about a half an hour talking about. So I'm going to condense about a half an hour to 45-minute presentation into 5 minutes. So obviously there'll be a lot of holes in it, so feel free to ask questions as you see fit. All right. What I'm going to talk about is something called PRISM and Merge, and you'll see why it's called PRISM here in a minute. What I'm going to talk about is an analysis we've done on the technical feasibility of reducing greenhouse gases, primarily CO2 in the electric sector in the United States. And what we've done is we've sort of built off I think most of you are probably familiar with the Energy Information Administration in the United States that does the annual energy outlook. And one of the things they do, of course, is to make an estimate of CO2 emissions from the whole economy, and in particular from the electric sector. And so what this chart here shows is what the CO2 emissions are from the electric sector going forward in the absence of any kind of climate legislation. So we thought is, well, look, let's kind of look at, say, if we could really push energy efficiency more into the economy than what the Energy Information Administration predicts. If we could push renewables harder, if we could get nuclear power, what do we think nuclear power is going to look like in the future? What about carbon capture and storage? What are the opportunities for that? Plug-in hybrid electric vehicles, while that's really not part of the electric sector, certainly the plug-in electric vehicles have to use electricity. So what we try to do is to say, what's the opportunity? What's the feasibility of reducing greenhouse gas emissions going forward into the future? And again, this is not an economic analysis. This isn't and this does not mean it's policy recommendations. I want to make that very clear. These are not policy recommendations. It's just how do we play off what EIA has done and what are the opportunities for reducing greenhouse gases going forward into the future. So we made some assumptions, and these are the assumptions we made. That in the EIA, they estimate load growth to be roughly 1%, 0.95% per year for electricity demand. We said, with energy efficiency, more energy efficiency in the marketplace, bringing technology into the marketplace, we can reduce that by half, by roughly 0.5% per year. We can also improve the efficiency of the whole transmission and distribution system by roughly 20% and reduce those losses. In this model, or in our analysis, we assume that renewable portfolio standards, like roughly 15% RPS, will be across the United States by 2030. That there will be a significant amount of new nuclear capacity built. EIA assumes 12.5 gigawatts by 2030. We assume 64 gigawatts, just because so many nuclear power plants are already in the queue. In terms of efficiency of power plants, they've made some estimates of how coal-fired power plants, natural gas-fired power plants in the future, what their thermal efficiency will be. We've pushed that even further. We believe that we can go better than what EIA is assuming, and you can see the numbers here. Likewise, since there's no carbon policy right today, EIA has no carbon capture and storage in their assessments going forward. And we've assumed that by 2020, all power plants that are built in the United States, all coal-fired power plants, will have 90% control of carbon dioxide through carbon capture and storage. Likewise, electric transportation, they assume no plug-in electric vehicles. You can see we have something like 100 million vehicles will be in the market by 2030. And then electro technologies, that we can replace some of what is now used, fossil fuels that are used in industrial processes, that some of that can be changed out for electricity going forward, which will also reduce the carbon footprint. So that then gets you to this PRISM, that this is what we think the technical feasibility is. If the research is successful, if the technologies are deployed, that this is what we can achieve in the United States from the electric sector. All right. What we then did is we kind of sat back and said, what is this going to cost? Is it really worth investing that $30 to $50 billion? It's going to cost $30 to $50 billion to bring these technologies to the marketplace. Does it really make sense? And the way we did it is we ran a model, one of these general equilibrium models of the world and U.S. economy, and said, what about if these technologies were not available, and what if these technologies were available in meeting a carbon reduction, something similar to what's being debated just down the road here, the Waxman-Markey bill, for example, and said, let's look at like an 80% reduction between now and 2030 from 1990 levels, and what's going to be the cost of complying with that with technology available and with it not available. And that's what this is. So the kind of the technology not available scenario, what we call the limited portfolio, says that carbon capture and storage just never becomes available. Just doesn't become available. Nuclear power is basically limited to technology that's out there today. Renewables, the costs decline, but they'll decline even more under the full portfolio of technologies. And plug-in hybrid electric vehicles will not enter the marketplace to the degree that we predicted before, and that end-use efficiency will be accelerated into the marketplace. And so we compared these two levels of technology and said, all right, let's look at and see what the value is. What this chart shows is that under the limited portfolio of technologies, if you've really got to reduce carbon emissions substantially between now and 2030, it's basically going to be demand reduction, i.e. energy efficiency, and just the high cost of electricity, people not using electricity, a renewables world, and a gas world, natural gas world. Under the full portfolio of technologies, when you have all these technologies available, you bring them into the marketplace, it's a different world. It's a renewables world. There is certainly energy efficiency under demand reduction, but coal with carbon capture and storage and nuclear play a big role, whereas natural gas is much more constrained. What does that do to the cost of electricity? If you've got the full portfolio of technologies, yes, there will be an increased cost of electricity. Roughly 80% increase. So there's no free lunch here when it comes to climate responding to CO2 reductions. But if you have a limited portfolio of technologies, the cost of electricity almost triples. And here's kind of the bottom line in terms of this is the kind of the present value of gross domestic product going forward. You have a limited portfolio of technologies, roughly $3 trillion to the U.S. economy between now and 2030, or 2050 actually. And on the full portfolio of technologies, having those technologies available is worth about $1 trillion. So for a $30 to $50 billion investment in technology, it's basically $1 trillion of savings. So that's sort of the bottom line. And my time is up, and I'd be happy to answer any questions about this when we have the chance.